Okay, I'm just gonna do a refresher for ionic equations. So it's a build up on what we did last week. So last week was the balancing chemical equations. Okay. So firstly, we need to cover what is state symbols. So state symbols basically tell you what states in compounds are. Okay, so there are four that you need to be familiar with. Okay, your solid, liquid, gas, which is your three states of matter, and then the last one is AQ, which means aqueous. Okay, aqueous means dissolved in water.
Sorry, I came back. I can't help my mother fix the sofa. Uh,
It's okay.
my
Can
bad. Can we start from the start? Because I wasn't
this
here.
is the start. Yeah, this is the start. Yeah. So we will just covering what exactly are state symbols lah. Okay, so state symbols basically just tell you more information about your reactants and products. Okay, so what type of state is it? Your three states, okay, your usual three states of matter, or one more, which is the aqueous. Yeah, aqueous just need to know that it is your dissolved in water state. So when you have things like salt, right? Salt dissolved in water is definitely not considered solid anymore, but then it's also not liquid because you didn't heat it up and melt it up. Okay, so aqueous state basically means dissolved in water. Need to be familiar. Okay, so you will see these four coming out as state symbols. Okay. So over here, I have an example. For example, like when magnesium burns in oxygen, it forms magnesium oxide. So first, usually the question will start like this. They will give you an unbalanced chemical equation. Then they will ask you, can you write a balanced chemical equation with state symbols? Okay, so firstly, you need to do is go and balance the chemical equation. So use all the knowledge that we learned last week. Okay, the one here you see on the second line should be the balanced chemical equation. So your left side, which is your reactant, and your right side, which is your product, right, should have equal number of each element. Okay, I shouldn't be unbalanced already. Okay, so then how do we assign the state symbols is like as follows. Okay, so we know the first one here, right, is magnesium. So pure magnesium is a metal, right? Metal at room temperature confirm has to be solid state one. Okay, so Mg, we will assign the bracket S to tell us that actually this one is in solid state. Okay, the next one will be O2. So O2 is oxygen gas, right? At room temperature is already a gas. So I'm just going to put it as bracket G to indicate gas. Okay, then lastly, your magnesium oxide is an ionic compound. This one you learned before. I remember how to identify. Okay, this is a metal plus a non-metal.
Wait. So oxygen O2 is two oxygen atom, right?
Yes, correct. Need to know
Oh,
that the oxygen that you're breathing in is O2, not
okay,
O.
okay.
Yeah. Then magnesium oxide is our ionic compound because it's made out of one metal and one non-metal. Okay, so this one being an ionic compound, remember we learned all of the properties is that in room temperature is a solid lah. Okay, they have very high melting boiling point. So at room temperature, it must be a solid. So I allocate the S here. Okay, so the whole balanced chemical equation, including the state symbol, should look like this. Okay, if the question asks you to write in with state symbol and then you miss out one, right, straight away it's -1 mark rate. So you have to be very, very careful when you answer this kind of question. Yeah, everything must assign correctly. Okay, so another example, so this one should be quite fast one. When I pass electricity through water, I form hydrogen and oxygen gas. Even the question also tell you already is gas. So it will help you with your allocation of your state symbol later. Okay, so unbalanced chemical equation, you will start with water to form hydrogen and oxygen. Balance it using what we learned last week. Okay, then now you need to allocate the state symbols. Okay, so water at room temperature is a liquid. So we will put a bracket L here. Okay, then hydrogen and oxygen are gases at room temperature, although mentioned here in the question already. So that need to allocate the bracket G to all of them. Okay, so then this one will be your balanced chemical equation with the state symbols. Yeah. Okay, so this example I will skip. Okay, then we move on to what exactly are ionic equations. So some reactions, right, they actually occur in water. Like for example, if I add acid to an alkaline solution, everything is occurring inside the liquid state. Sorry, the aqueous state. Okay, when they are all dissolved in water, everything is dissolved in water. Okay, so you have things like ionic compounds, right? Remember, ionic compounds, one of the properties is that they can dissolve in water. Okay, so when they are added to water, they form ions in aqueous state. Okay, when they dissolve in water. So these ions, right, may or may not be involved in the reaction that you are describing. Okay, so may or may not. Okay, so ionic equations, what exactly you're focusing on, right, is that the ions that actually do go through a chemical change. Okay, I want you to focus on the ions that actually go through a chemical change. Then anything that actually doesn't change one, right, we will ignore them. Lah. Okay, so anything that does not undergo a chemical change, these are known as your spectator ions. They're just there to watch the show only. Lah. Yeah. Okay, so I think the best way to show you is an example. Okay, so these are some of the steps to adopt when formulating ionic equation. So I will not go through exactly the steps. I will show you using an example. Yeah. Okay, so I have a table here with all the common compounds and what ions they form when they dissolve in water. So this one also need to be familiar. Lah. Okay. Okay, so showing you an example. Let's say we have solid magnesium, okay, dissolve in hydrochloric acid solution to form magnesium chloride and hydrogen gas. Okay, so the first step that you need to do in order to derive what is the ionic equation, right, is you need to balance the equation first. You need to give me the whole equation first. Okay, so let's write down what magnesium, right, solid. So we write like that. Okay, magnesium with a bracket S, dissolve in hydrochloric acid, so HCl. Okay, solution means it is dissolved in water. So this one, the state should be AQ. Okay, to form magnesium chloride, which is MgCl2. Okay, this is a salt, so it is also dissolved in water. Okay, and then plus hydrogen gas, so H2 gas. Then from here, you just need to balance. So after balancing, you add the 2 here, everything should be okay already. So that's how I get my first step here. Okay, then the second step that you need to do is to go and identify all the compounds with aqueous state. Why? Because all these compounds with aqueous state, right, actually they don't exist as like that in aqueous state. Right? Like for example, your HCl, when you dissolve it in water, it doesn't still stick together as HCl. Actually, it will split up into H plus and Cl minus. Okay, so they will split up into their ions. And then same thing for the MgCl2. Okay, this one is an ionic compound. So when you dissolve it in water, all the ions are torn apart, right? They don't stick in their crystal lattice structure anymore. So they end up forming every MgCl2 splits up into one of the Mg2 plus and two Cl minuses. Okay, then the remaining all those not AQ one, right? Those no change one, because so Mg solid and H2 gas will all remain the same. Okay, so what we need to do next is then split up all the aqueous compounds into their respective ions. So for magnesium solid, no change. So over here, I keep it as magnesium solid as well. Okay, but then for HCl, I know that HCl splits into H plus and Cl minus. If I have two of it, means I will have two H plus and two Cl minus. So you can see here, this is how I split the ions up. Okay, only do this for all the AQ compounds. Okay, then the next one will be MgCl2. One of these MgCl2 actually splits up into Mg2 plus and Cl minus. So I split it up here also already. And then lastly will be the H2 gas, which nothing changed also over here. Okay, then all the ions, remember just to assign them the equal state also. They never change state yet. Okay, so then after that, after splitting up all your aqueous compounds, you need to find all your spectator ions. So which are the ions here, right, that actually don't go through any chemical change one. So the method here is just for you to go and check one by one. Okay, first one here, we check magnesium solid. After the reaction, magnesium solid became this thing, which is Mg2 plus aqueous. So you can see, right, the state change, the charge also change. So means actually there is a chemical reaction, and I want to keep it in. Okay, anything with change, I will keep it in the reaction. Okay, so this one I want to keep it in. Then the next one will be H plus. H plus started off like this, 2H plus aqueous. After that, it became H2 gas. So over here, also there's a change instead of aqueous become gas, 2H plus become H2. So it's not the same. Okay, there is a chemical change. I want to keep it in. But then what didn't change actually is the chloride. Okay, you can check over here, you have 2Cl minus on the left side, but at the end of the reaction, you also end up with 2Cl minus. So this is what we call spectator ions. Okay, they never go through any reaction. They before and after they are the same thing. Okay, so after identifying all your spectator ions, then you want to remove the spectator ions. Okay, so simply copying down the whole equation, but just removing them, so ignoring them. Okay, just copy the whole thing, Mg, then with the 2H plus to form Mg2 plus and H2. Okay, so this one is your overall ionic equation. Okay, 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 can. So that was the recap. Okay, then I think now we will go through all the worksheet questions. Okay. So when calcium metal is added to nitric acid solution, actually everything in the question, they give you a hint as to what it is. Right? Calcium metal, nitric acid solution, produce soluble calcium nitrate and hydrogen gas. Which of the following is the correct balanced ionic equation? So remember all the steps. Firstly, right, you need to do is to find the overall equation, the balanced chemical equation. Okay, so we will start by copying everything down. Calcium metal is just simply calcium, and this is going to be in solid state because it is a metal. Okay, added to nitric acid solution. This one you need to be very familiar. What is the formula? Okay, nitric acid is HNO3. Okay, and then since they tell you it is a solution, means this one must be AQ. Okay, so this is in AQ state. Okay, to go and form your soluble calcium nitrate. So calcium nitrate, also go and familiarize yourself how to derive the formula ACA2 plus and NO3 minus. So you go and cross the thing and then form the formula. Okay. Soluble means it is also going to be aqueous state and then plus hydrogen gas, which is H2. Okay. So over here, we just need to do our balancing, which is to add, okay, calcium is balanced. NO3, I need 2. So I'll 2 here. Hydrogen, I have 2. Nitrogen, I have 2. Oxygen, I have 6. Okay. So this is the balanced chemical equation. Okay. Secondly, go and find all those AQ compounds because you need to end up splitting up all the AQ. Okay, so your AQ will be one here and one here. Yeah. So you must be clear that for every HNO3, it will split up into H plus
Is
and
it C?
D. No, not correct.
No? Oh.
Some got this thing. Yeah, they are keeping the
Oh.
specific ion inside.
Mm.
Yeah. Good try, though, good try. Yeah, I slowly explain that, then you see whether you get the best grade by then. Okay, so HNO3 will split into H plus and NO3 minus. Your calcium nitrate, which is CaNO3 2, will split up into Ca2 plus and 2 NO3 minuses. Okay, so I'm going to split everything and then at the bottom. Okay, so calcium solid no change because it doesn't split into ions. HNO3 splits into H plus and NO3 minus. I have two of it. So I will have 2H plus equals and 2NO3 minus equals. This is after splitting up my HNO3. Okay, to form calcium nitrate, which actually is just Ca2 plus equals and 2NO3 minus equals. Then lastly is hydrogen gas, which also doesn't split into ions since it's not AQ. Okay. Then the next step is for you to go and identify where is your spectator ion. So over here we can double check lah. My calcium actually there is a change because calcium from solid become calcium 2 plus. There is a chemical change. I want to keep it inside. This is not a spectator ion. Okay. Then my H plus there, my H plus also changed. My hydrogen from H plus became hydrogen gas, which is H2. The state also changed. So over here, there is a chemical reaction. I want to keep it in the reaction, in the equation.
So is it B?
Is it B for boy, is it?
Yeah. Because
Correct lah. Yes, yes. Okay, so your spectator ion is the nitrate, so we need to remove it. Okay, then we just copy down exactly what is remaining lah. Okay, so over here is your calcium solid plus 2H plus, okay, yeah, okay. Okay, and
yeah.
so the main thing that I think you need to learn is how to split the ions because that's where usually a lot of students will make careless mistakes also. So that as long as you're okay with that one, finding all the spectator ion, all that should be quite okay. Okay, can. We have another one here, which is iron 3 chloride added to sodium hydroxide. So I'm just gonna do it relatively quickly really. Iron 3 chloride is FeCl3. Solution tells me this is in AQ state. Okay, added to sodium hydroxide solution, which is NaOH. Solution also means it's AQ state. Okay, to form insoluble iron hydroxide. So iron 3 hydroxide is given as FeOH3. Since it's insoluble, right, it cannot be aqueous because it cannot dissolve in water.
So
So
solid.
solid, yes, very good. Okay, and then a soluble compound means it's the remaining lah. So I used up my iron and hydroxide, means the remaining should be your sodium chloride. Okay, and this one is aqueous. Okay, so over here we do a balancing. My Fe is 1, my C